This is to go over a problem that I ran out of time in class. And to do this, you're going to need your handout G03 Construction, page 11. So if you don't have that, pause the video and get that, and then join me here in a second, okay? All right, we went over the centroid, and this was in class. We talked about the fact that the segments, these was one of our 4 special segments, that they are concurrent, meaning that all 3 of them inside the triangle will run into each other at one point. We talked about the way to find those. You can find the midpoint, and then you connect. So if I found this midpoint, I would connect it to the opposite vertex. If I found this midpoint, I'd connect it. Find this midpoint, connect it, and then somewhere they would meet in the middle. And we also talked about the fact that that turns out to be the center of gravity. That if this was made out of, say, a piece of metal or something like that, that would be the point that I could balance it on top of a pencil or some sharp object. Okay, so if we don't have any more information other than the space, that's how we have to find it. But it turns out that on a coordinate grid, we have another way to get this, and it's actually pretty easy. Okay, so I'm actually going to label this A, B, C. Okay, triangle ABC. And instead of finding the midpoint and connecting and finding the intersection, what I'm going to do is I'm going to identify where points A, B, and C are. So this A is at -2, +2, right? X comes first, Y comes second. B is at 1, 2, 3, 4, -1. And C is at 1, 2, 3, 4, 5, -6, 1, 2, 3, 4, -4. Okay, so I've just identified where these 3 points are in space. And now we're going to use an algebraic idea, but it's really the same concept of why the centroid is the center of gravity. It's the fact that it averages out the x distances and the y distances. It finds the average of those distances. So what we can do is we can say, hey, our x's and our y's are, I'd like to list them here in a little table. Okay, and these are the 3 x values, these are the 3 y values. I'm just going to add them up and divide by 3. That's averaging, right? So I get -8 plus 4, -4, divide by 3, there is my x coordinate. Okay, -5 plus 2 is -3, divided by 3, it's -1. Okay, this is the location of the centroid. I'm going to go -4/3, that's -1 1/3, so that would be right about there, okay? And then I go down to -1. That would be the location of the centroid. And if I wanted to kind of verify that, well, I could say, hey, if I were to draw the segments that go through, right, that should be the midpoint of AC. And I could draw the segment here that goes through, and this point here should be the midpoint of AB, and I could go with the third one here, okay, and that should be the midpoint of CB. And it turns out you can verify that algebraically, but hopefully you can see that this is a very fast and easy way to get the centroid if you're given the 3 points. In fact, they don't even need to be graphed. If you're given 3 points, you just add up the x values, divide by 3, add up the y values, divide by 3, and you get your average, and that would be the centroid.